Okay, I think I'm recording. Okay, now I did hear you when you said that sometimes my terminology, the terminology on the test, looks a little different than the questions and the terminology inside WebAssign. So I have heard you, and I'm trying to make those adjustments, and I'll make those adjustments again back on the test so that we can make sure that we know exactly what we're talking about. The downfall to that is I think it's a little bit small, okay? So I am going to see what I can do to maybe make that a little bit bigger for you. That's doing pretty well. Okay, I can work on that. That is a fixable, that is probably something I can fix. So I'll try to make sure that it's big enough. Oh, there's a whole bunch of screen that I don't have. Kind of cool. Okay, so here we go. Write the quadratic function in standard form. Now, you may think of standard form as ax squared plus bx plus c. That is how I think of standard form. When we start talking about polynomials, that is how they are going to define standard form. But when we are talking about quadratics, when they say standard form, they mean vertex. They want us to do it in the vertex form. And the form for that is f of x equals a times x minus h squared plus k. Okay, what is h and k? Vertex. Good. H and K is your vertex. So that is what we're doing. We are trying to get 2x squared plus 8x plus 7 into our vertex form to where we can identify our vertex. This one is different than the one that we did on Thursday. This one is different because we have a 2 in front of our x squared. We didn't have anything in front of our x squared, not even a negative. And so now we've got to do this differently. Or we have to think about this a little bit differently. So this is what I'm going to do. Okay. I have f of x equals 2x squared plus 8x. And then I'm going to move that plus 7 off to the side. Okay, I'm moving that plus 7 off to the side, so I am only going to deal with that x squared and my x portion. Okay, this is where students get confused. I am going to factor out a 2, but only in those two numbers. I'm not going to do anything with the 7. I'm going to factor out a 2 in those two numbers. Okay, so I've got f of x equals 2 times x squared plus 2 times what gives me 8? 4. Okay, now, so then I'm going to finish a trinomial, and I've still got that plus 7. Please notice that that plus 7 is outside of what I'm dealing with right now. That plus 7 is outside what I'm dealing with right now. Okay? So, I want to finish, I'm going to complete the square. That's what it's called, completing the square. So, what is half of 4? 2. And what's 2 squared? 4. So I am adding 4 right there. So I'm adding 4 right there. Now, I have got to keep this equation balanced. When we solve something like this by completing the square, we just add that plus 4 to the other side, right? We do plus 4 on one side and we do plus 4 on the other side. But on the other side of this, we've got f of x. We're talking about a function. So I am only working on one side of the equation. Okay? I'm only working on one side of the equation. So last week when we did this, we added the opposite on the outside. Okay, so I had plus 4 on the inside, I added negative 4 on the outside. I am going to do this, but I can't do that yet because I haven't actually added only plus 4. Any ideas what I actually added? Yes, plus 8. How did you get that? Good. It's in the parentheses with the 2 outside. Okay? That's where students make mistakes, right there. They forget that they've got to multiply this number by whatever's out here. So what have I actually added? 8. I've actually added 8. So in all this part right here, I've added 8. So what do I want to do outside the parentheses? I'm not going to add 8. Minus 8. I have to do the opposite because we're all talking about one side of the equation. We're not doing 2 different sides. We're doing one side of the equation. Okay? So now I am where I want to be. Okay, so I have f of x equals 2 x plus 2 squared. Okay, that's a perfect square trinomial by design. X squared plus 4x plus 4 factors to x plus 2 squared. And then I'm left with minus 1. Okay? Am I able to identify my vertex from this? Yes, what's my vertex? So remember my original formula is x minus h. So what would that be? You got it. You're absolutely right. So my vertex here is negative 2, negative 1. I'm going to go ahead and plot that. So negative 2, negative 1 is right there. Negative 2, negative 1. Okay? Now, I got the graph just off the internet. I think you're doing multiple choice a lot on WebAssign. But do you see this vertex, axis of symmetry, and x-intercept? That is straight from WebAssign. That right there is straight from WebAssign. Okay? So your vertex, we already know, is negative 2, negative 1. Okay? Now, something I am going to consistently ask for is the y-intercept. The y-intercept. How do I get the y-intercept? What do I do to get the y-intercept? Good. Plug 0 in for x. Okay? Now, one of my student tutors, supplemental instruction leader, when I was working, she said, well, Alicia, have you ever told your students just to cover up all the x's with their finger? And I was like, what? And she said, well, tell them just to take their thumb and put their thumb on top of like the 2x squared and the 8x. Do you see that? Does it work? It works every single time. Because what you're doing is you're plugging in 0 for x. So anything that's got an x in it is going to be 0. So I am just left with that constant right there. Okay? So where does this graph cross the y-axis? At 7. Okay? And that is something that you'll be asked for from time to time. So my y-intercept here is 0, 7. Okay? Now, I've got enough information I can probably go ahead and draw this, though I am not fabulous at drawing these things like this. Okay. Now, something that we did not talk about on Thursday was something called the axis of symmetry. The axis of symmetry. So I want you to look at this line, and I am going to draw this line through my vertex. I am drawing this line through my vertex. And if I was a better parabola artist, and I folded my parabola on top of that line, what could you tell me? What would happen? I really am that bad of a parabola artist. It is. It's like a butterfly. Okay? That is our axis of symmetry. Okay? Your axis of symmetry is always a vertical line. Okay? It's always a vertical line, and it's always x equals the x value of your vertex. So what is the x value of my vertex? -2. Did I draw a line at x equals -2? I did. That's exactly what I did. So my answer to the axis of symmetry is x equals -2. Okay, yes ma'am.
So when we're putting this into
WebAssign,
we have to put the x equals.
it will ask you to put the x equals, because if you just put the -2, you're just telling me a value. X equals -2 is a line. And that is something that comes up a lot when we do rational functions. Students don't label their asymptotes as lines. And it is, that is something that we want to be aware of. So that's an excellent question. Thank you for asking it. You do want to be sure you've got the x equals, because we are talking about a vertical line there. Okay, now I've kind of written about it, but we've got one more thing that we've got to answer here. Okay, what's the other thing that we've got to answer? We've got to answer the x-intercepts. Now, I'd like to factor that. Okay? I always want to factor. Factor is just my go-to. Can I factor it? Did you say yes?
Maybe.
Maybe. Oh, but we're going to try. Okay. So, if I was going to factor this, I need a product and I need a sum. I don't have a 1 in front of my x squared, so how do I get my product? How do I get my product? Okay, well, I can't take a 2 out, but I do something with that 2. What do I multiply that 2 by? Yes, good. 2 times 7. What is 2 times 7? 14. Okay, 2 times 7. This is the AC method. Okay, so my product is 14. What's my sum? 8. Okay, my sum is always that B value. So there's my product, there's my sum. Are there two numbers that multiplied together give me 14 and added together give me 8? There's not, okay? 2 times 7 equals 14. When I add those together, what do I get? 9. 1 times 14 gives me 14. When I add those together, I get 15. It doesn't work, okay? This cannot be factored. So we're going to have to do something else. We're going to have to do either the quadratic formula or completing the square. Now, if you had me last semester, I personally do not do completing the square when my A value is not 1. Okay, I want my A value to be 1, and that is not the case. So right here, I'm going to put -4 plus or minus the square root of 2 over 2. Yes?
On WebAssign, if it asks us to write it in like that, how would we do the plus or minus thing? Is there, do you know?
Oh, that is a great question. Actually, I ran into this recently. There is not a plus or minus. Or I have not found the plus or minus. Thank you for saying that. You would have to do -4 plus the square root of 2 over 2 and comma 0. So that's your ordered pair right there. And then you would do -4 plus the square root of 2 over 2. Oops, not plus. This one would be minus the square root of 2 over 2, comma 0. That is a fabulous question, because that will come up.
So you have to write both of them.
I'm sorry?
So you have to write both.
You do have to write both of them. You do. Thank you for bringing that up. Are we ready to do something else? Well, we're doing the same thing, just on a different problem. Okay, are we ready to try another one? Okay. I'm going to use the quadratic formula. Okay, and this is something I will give you on your test. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And I guess I need to write down the function. Okay, so my function is f of x equals 2x squared plus 8x plus 7. Okay? So, when we identify my A, B, and C, we look at it in the form ax squared plus bx plus c. We're looking at it from that perspective. Ax squared plus bx plus c. Okay? So my A value is what? Good. My B value and my C value. Good. Okay. So I'm going to keep the parts of the quadratic formula in blue, and I am going to put the A, B, and C in red so you can see what we're working with. Okay? So I've got negative B plus or minus the square root. Whoops. I actually meant to put values in there. Sorry. Okay, so I've got negative 8, because our b is 8, plus or minus the square root of 8 squared minus 4 times my a value times my c value. Okay? And all of that is over 2 times a. Now, students usually do pretty well here, but they make some algebraic mistakes. They understand what the quadratic function does. They understand what the quadratic formula is trying to solve for, but they make mistakes. And typically the mistakes that are made are inside that square root. So let's look at that. I'm going to deal with that first. So I have negative 8 plus or minus the square root. What is 8 squared?
64.
Good. Then I have negative 4 times 2. What's negative 4 times 2? Negative 8. And what's negative 8 times 7? Negative 56. Okay? Right there. That is all over 4. Okay? So I have negative 8 plus or minus the square root of 8 over 4. Now, this is another area that students make mistakes. Sometimes they'll stop. One of the things they do is they just stop. The other thing they do is they're like, oh, 4 goes into 8 and 8. Okay? You can't do anything with this 8 in this 4. Okay? You can't do anything with those because one is inside and one is outside. Okay? So I've got to deal with that first. Now, the square root of 8 has a perfect square factor in there. That means I can break 8 down, and one of the numbers that I'm multiplying, I can take the square root of. Okay? Any idea? 2 and? Good. Good. And that still stays over 4. Okay? Now, I can take the square root of 4. And when I take the square root of 4, where do I put that? Good, on the outside. So I have negative 8 plus or minus, what is the square root of 4? 2. So I have 2 on the square root of 2 over 4. Now, I have something common here, here, and here. If it's not common in all three places, you can't simplify it. Think about it the same way that you would think about -8 plus 2x over 4. Okay? The -8 and the 4 cancel or simplify, but the 2 and the 4 I still have to keep as 1/2. Okay? Now I could change this to a 2, this to a 4, and this to a 1. I could do that and have -4 plus x over 2. Okay? But I can't just cancel out that -8 and that 4. So here, my 4 is going to become a 2, my -8 is going to become a 4, and my 2 is going to become a 1. This is where I typically stop. I usually stop right here, okay? I can't cancel out the -4 and the 2 because that 2 belongs to both. I can't cancel out the square root of the 2 and the 2 because one is inside the square root and one isn't. Now, what I could do, and I'm back up here with my blue, could I do -4 over 2 plus x over 2? Am I allowed to do that? Yes. And then I get -2 plus 1/2 x. Okay? I could do that. I could also do that here. I typically don't, but I could. Okay? If a student wanted to go further, so this is what I think your answer is. Well, I know this is what your answer is. If a student wanted to do -4 divided by 2, and then have plus or minus the square root of 2 over 2, that's okay as long as you've got that right there. Make sure that you've got that. Okay? Okay. So now I'm going to go back to my previous screen because I've got my x-intercepts. Here we go. Whoops. Here we go. Okay. I have f of x equals -x squared plus 6x minus 8. -x squared plus 6x minus 8. Okay? Now, we're in the same situation that we were when we had a 2 in front of our x squared. Okay? We're still going to have to deal with that negative. Now, the negative tells me the direction of my parabola. So is my parabola going to go up or is my parabola going to go down? It's going to go down because of that negative right there. Okay? So, let's start looking at this. I have to take out a -1. Just like I took out a 2 last time, I've got to take out a -1 this time. So I'm going to have a -1 on the outside of my parentheses. Now remember, my -8 is going to hang out here. My -8 is going to hang out here. When I take a -1 out of the -x squared, I'm left with positive x squared. When I take a -1 out of positive 6x, what am I left with? Excellent. Okay? Now, I go back. Okay? I take half of -6. What's half of -6? -3. And what's -3 squared? 9. Okay. So I am adding 9 right here. The number one mistake that students make right here is then they take the positive 9.
And put a -9 on the outside, but really it's positive 9 on the outside.
We got to put positive 9 on the outside. So let's talk about why we have to put positive 9 on the outside. Okay? In the one before this, what did we have to multiply that 4 by before I added it or subtracted it from the outside? What did I have to do? The 2. Okay? So here, before I decide what to add on the outside, I need to multiply that 9 times what? -1. Okay? So what I have actually added is the negative value. Okay? So what I have added right here is -9. So how do I undo that? Because I'm all on the same side of the function. I can't do anything with the f of x because that stays there, and I've got to keep it balanced.
You add positive 9?
I add +9. Okay? So that seems strange to some students because we put a +9 on the inside. But you have to multiply this +9 times the -1. So what I actually did here was -9. And because we're talking about the same side of an equation, this number and this number have to be opposite. Okay? If you get past that, you'll be fine. Okay, so now we have f of x equals -1, x squared minus 6x plus 9. What does that factor to? By design, we've created a perfect square trinomial. Okay? What is x squared minus 6x plus 9? What two numbers multiply together give me 9, add together give me -6? Almost. -3 and -3. Okay? So this is x minus 3 squared plus 1. Okay? So that's my vertex form right there. The -1, the x minus 3 squared plus 1. Okay, what's my vertex? What's my vertex?
3, 1.
+3, good, and excellent. Good, 3, 1. So I'm going to put my vertex right there. 3, 1. Okay, what is my y-intercept? What's my y-intercept? Good. So that's 0, -8. Okay, so I can draw my parabola. I do pretty well, and then I hit something. Okay, now we just learned about axis of symmetry. My axis of symmetry always goes through my vertex. It always goes through my vertex. It is always a vertical line. So what is it? X equals 3. Okay, so don't forget your x equals part. Your x equals part, because it is a line. It is a line. Okay, now we've got to find our x-intercepts. Now we want to find our x-intercepts. So I am going to, we're going to do our x-intercepts down here. So I have f of x equals -x squared plus 6x minus 8. And this can be factored. Now, there is a GCF here that we don't always think about, okay? There is a GCF here that we don't always think about, and that GCF is -1, okay? Because when I pull this -1 out, it makes it a very straightforward factoring problem. Okay, so I'm going to keep that -1 on the outside, and this factors very nicely. Okay, what two numbers multiplied together give you 8, and added together give you -6? -4 and -2, because whenever we have a positive product, both numbers have to be either positive or negative. So we're going to have x minus 4 and x minus 2. Now, some terminology that I want you to start getting used to. These right here are factors. Okay? X minus 4 and x minus 2, those are factors. I am going to set each one of them equal to 0, and I am going to get a solution. Okay? So, x minus 4 and x minus 2 are factors. X equals 4 is a solution. X equals 2 is a solution. Okay? Okay, so my answer here is going to be, if I put it in ordered pairs, is going to be 4, 0, and 2, 0. That's a great question. So the question is, what about the negative 1? And there's my x-intercepts right there. We only have to worry about our GCF if there's an x in it, okay? So negative 1 is a constant. And so if I put negative 1 equal to 0, because it is a factor, if I put negative 1 equal to 0, I have to throw it out because negative 1 does not equal 0, okay? So once we factor out that GCF, it would be like factoring out a 2. Like if everything was even, we could factor out a 2, and we just ignore that 2. That's a great question. I'm glad you brought that up. Okay? Huh. I know I've been talking for a lot longer than 9 minutes, right?
Yes.
Huh. Well, we're going to see how this recording goes. We'll see. We're learning. Yeah, I've been talking a lot longer than that. Oh. It starts over at each slide. I'll go back and deal with that later. Okay, here's another situation where I have pulled the directions from, okay. I'm learning, guys. Be nice. It's okay to laugh at me, I don't care. Okay, here we go. Well, maybe. Okay, I'm done. I'm going to stop right there. Okay, what the directions say, and I'm just trying to make it bigger so you can see it. Write the standard form of a quadratic function. In this book means vertex. Okay? Whose graph is a parabola with the given vertex that passes through the given point. Let x be the independent variable and y be the dependent variable. You don't really need to worry about what that means, except that that means your answer is going to be y equals something instead of f of x equals something. That's all that means. Okay, now, our form that we're going to deal with is y equals a times x minus h squared plus k. Okay. Oh, there's the point, negative 2, 5. Okay. So, we already know the h and the k, correct? What's the h and the k? Negative 2, 5. Excellent. Okay. So, we're going to have y equals a times x plus 2. Why is it plus? Good, because negative makes a positive, okay? The formula has a minus sign. Our x value has a negative. Now, students usually do fine right here, and then they just assume their a value is 1. That's what students do. They just assume their a value is 1. Okay? Don't make that assumption. Here I have y equals a times x plus 2 squared plus 5. Now, I am given another point. What does the point 0, or what does the value 0 and 9 represent? what's the coordinate? What coordinate does 0 associate with, and what coordinate does 9 associate with? X and Y, okay? So this 0 can be an X value, and when that 0 is X, my Y value is 9. So the way I solve this, the way I figure out what A is I plug in 0 for X, and what do I plug in for 9? Or for Y? 9. So we have 9 equals A times 0 plus 2 squared plus 5. Okay? What is 0 plus 2? 2. And what is 2 squared? Okay? I'm going to subtract 5 from both sides. When I subtract 5 from 9, what do I get? Okay. Now I need to divide both sides by 4. What's my A value? 1. My A value is 1. Now, A equals 1 is not your answer. A equals 1 is not your answer. Your answer is when we go back up and we plug it in. So I have Y equals X plus 2 squared plus 5. Okay? So that right there is my answer. Okay? We are going to do another one, or you are going to do another one. Okay. So I am going to give you 3 minutes. Yes, you would put it right here. And you could write the 1 down if that makes you feel better, just to kind of help keep the place value. Yeah, that would be it. You wouldn't have to do anything else with it. You wouldn't distribute it or anything. Good question. Okay, here we go. I'm scared to try to make it back bigger. I did better this time. Sort of. Well, there's a little tilt right there at the end. Okay, write the standard form. And that means vertex. Okay, so I'm going to have Y equals A times X minus H squared plus K. Okay, you have your vertex and you have your point. So I'm going to give you about 3 minutes to do that. Okay. I'm hoping that you have Y equals A times X minus 1 plus negative 2 or minus 2. Okay. And that is what you want to stick in for your X and your Y. Okay. Students very often plug that intercept or that vertex in without any problem. Okay? They plug the 1 in for H, the -2 in for K. Okay? Sometimes then they don't know what to do with that X and that Y. How do I find out my A value? You take that additional point and you plug it in for X and Y. So I have 14 equals A times -1 minus 1 squared minus 2. Okay? What's -1 minus 1? -2. Okay, and so I'm going to have -2 squared. What's -2 squared? 4. Okay, so I'm actually going to write that as 4A. Okay, what do I add to both sides to get rid of the -2? Good. So I have 16 equals 4A. What's A? 4. Now, A equals 4 is not your answer. Your answer is Y equals 4 times X minus 1 squared minus 2. Okay. Can I go to the next screen? We good? That's not too bad when you think it through. When you think through what you're doing. Before we move on, I want to talk a little bit about when we solve a quadratic. When I tell you to solve this quadratic, what am I solving for? What am I solving for? What is a solution? I heard it. We're actually solving for the x-intercepts when we're solving. Okay, so we're solving for the x-intercepts. Okay, it's called a solution. Can also be called a zero. My calculus teacher always calls it roots. Roots. And I'm like, really? Because I tell my students that's kind of an old term. But he calls them roots. Okay, now, how can we solve a quadratic? How can we solve a quadratic? Say that again. You do set it equal to 0. You're absolutely right. No matter which method you're using, you're going to set it equal to 0. Once it's set equal to 0, my preference is to see if I can do something. It can't be done in all of them. We were able to do it once today. Factor. Okay? So one way you can solve a quadratic is to factor. What's another way? Completing the square. And I'm going to do one of those super quick just so we can remember how to do it. Okay, completing the square. And what's the last way? Good, quadratic formula. You can use any of these. You are going to get the same answer no matter what. You're going to get the same answer. It doesn't matter if you factor, if you complete the square, or you use the quadratic formula, you're going to get the same answer. You have to simplify with completing the square and the quadratic. And you've got to know for sure how to do either completing the square or the quadratic formula, because not everything can be factored. Okay? Not everything can be factored. So you've got to know how to do one of these. Okay? You've got to know how to do one of these because not everything can be factored. Now, I'm going to erase, I'm going to erase right here, and then I'm going to do a completing the square for you. And I think we did a completing the square on the first day, but we're going to do another one. Okay? So completing the square, this is what I'm doing right now. I've got x squared plus 10x minus 2 equals 0. Okay? And we always set it equal to 0 just to decide what we're going to do. Okay? Equals 0. Now, this can't be factored. There are no two numbers that you multiply together and get negative 2. That gives us a product of negative 2 and a sum of 10. There are no two numbers. So I've got to do the quadratic function formula or completing the square. Now, for those of you that had me in 131, I like to do completing the square when there is a 1 in front of my x squared. And what kind of number is in front of the x? Even. Okay, that's when I like to do completing the square. If my a value, which is in front of my x squared, is not 1, and my b value is not even, then I'm going to do the quadratic formula. That's just what I'm going to do. Okay? But if a is 1 and b is even, then I'm going to do completing the square. So, first thing we do with completing the square is we take that negative 2 and we put it on the other side. When I take that negative 2 and I get it on the other side, what do I have on the other side? Positive 2. Okay, so I have added 2 to both sides. Okay? Now, I take half of 10. What's half of 10? 5, and I square it. 25. Now, I am dealing with two different sides of an equation. So can I add the same thing to both sides? Yes. That's because I'm dealing with two different sides. If I wasn't dealing with two different sides, I couldn't do that. Okay? Now, by design, I have created a perfect square trinomial. That means it factors nicely. What two numbers multiplied together give me 25 and added together give me 10. 5 and 5. So I'm going to have x plus 5 squared. Okay? Now, I take the square root of both sides. This is where students make a mistake. When I take the square root of 27, what do I have to put in front of it? Plus or minus. Okay? Plus or minus. So I now have x plus 5 equals plus or minus the square root of 27. Okay? I subtract 5 from both sides. And this is where students want to stop. But you are not done. You are not done. Anybody see what I can do? Say that one more time. There's a perfect square inside 27. What is that perfect square? Good. That is cubed. You're correct. I don't know who said that. That is cubed. Okay? That is 3 cubed. But we are taking the square root, so it's cool that it's cubed, but that doesn't get us anywhere. But it is cubed. Okay, what's the square root of 9?
3.
Good. And you stop. That's where you stop. Okay, you can't combine the negative 5 and the 3 or anything like that. Now, if inside WebAssign, if it wants just your answers, if it just says what's the x values at the intercept, then you would write negative 5 plus or minus 3. Trying to show you what to write inside WebAssign. Negative 5 plus 3 on the square root of 3. Then you would have to do another one, negative 3 minus, or negative 5 minus 3 on the square root of 3. Now, if it just wanted to know the solutions or the zeros, that's what you would write. If it said it wanted to know the x-intercepts, I would put a 0, because then I've got an ordered pair. Okay? This is the x value of my ordered pair, and this is the y value. Okay? And we didn't deal with a lot of that in 131. And we're going to deal with irrational and even imaginary solutions in 144. Okay. Any general questions or specific questions about quadratics? So we're not completely leaving quadratics, but we are going to expand on other polynomials. Okay? Can I go to the next screen? Okay. So we are looking at polynomial functions. Now, we've actually been talking about polynomial functions since the first day of class. Now we're just giving it a name. Okay, and here are some characteristics of a polynomial function. Your polynomial function must be continuous. Okay, that means it's a smooth curve. A smooth curve. The domain of this polynomial function must be all real numbers. The domain must be all real numbers. So immediately, we cannot have a variable in the denominator of a fraction. And what else can we not have? A variable where? Square root. Okay? Because we have to limit the domain if we have a variable in either of those situations. Okay? My exponents must be whole numbers. They can't be negatives or fractions. So my exponents must be whole numbers. I think we got it. Okay? That's what a polynomial function is. Now, there's some specific types that we're going to talk about. Okay? Is it okay if I go ahead and move to the next screen? I think I still got people writing, so I will pause. Okay, I think I'm good. So now I'm going to talk about specific types of polynomials. Now, we have been talking about a constant since before you were in kindergarten. Okay? A constant has a degree of 0. And an example of a constant are all your numbers with no variable. Okay? Now, if -3 had an x to the 0 with it, what is x to the 0 power? Does anybody remember? It is 1. Good. So the reason that this is considered a degree of 0 is because of that x to the 0 power gives us 1. So any of my constants could be multiplied by x to the 0 power and it doesn't change their value. Okay? Now, we've been talking about linear functions for a long time. Okay? A linear function. What is the degree of a linear function? What is the x? So if I've got y equals 4x plus 2, what is the exponent associated with that x? It is? Okay. So linear functions have a degree of 1. Degree is always associated with your highest exponent. Okay. Quadratics we've talked about. What is the degree of quadratics? What's your highest exponent? 2. Good. All of your quadratics have an exponent of 2. Okay, if it doesn't have an exponent of 2, it's not a quadratic. Okay, so constants, linear, and quadratics we've talked about. We've been doing lots of different work with. We have briefly touched on what's called a cubic. Okay, a cubic has a degree of 3. That means their highest exponent is a 3. The other one that we'll talk a lot about is a quartic. Okay, that has a degree of 4, like a quarter. Okay? So you can have x to the 4th power. Now you can have other exponents. You are always looking at the highest exponent. Your degree is associated with your highest exponent. Okay, it's associated with your highest exponent. Okay, now, I would wait until I write all my good stuff on this next slide, but then I'd take a picture of it even when you write everything. Okay? So what I have right here is I have a way for us to determine the end behavior of a graph. And I am not going to get all that in, so I'm just going to erase it and I'm going to start over. Okay? So this helps us determine the end behavior of the graph. Okay? That is the end behavior of the graph. Okay? And when I say end behavior, I'm talking about where these arrows are. That's what end behavior means. Whatever happens in the middle, I don't care what happens in the middle. I am talking about the end behavior of my graph. That's what I'm talking about. So what this is a leading term test. Okay? This deals with your leading term. And it does not matter what order your monomials are in. Your leading term is always the term that has your highest exponent. It doesn't matter what order it's in. You are always going to zone in on that highest exponent. That's what you're going to zone in on. Okay? Okay. Now, if I have an even power, do you see this right here? Talking about an even power. An even power is x squared, x to the 4th, x to the 6th. Okay? Think about what you know about quadratics. Okay? If I have something that is squared, the end behavior of my parabola is either both going to go up or both are going to do what? Go down. Okay? So an even power, it doesn't have to be a quadratic, but think about how a quadratic works. And the same is true for all even powers. Your end behavior, both go in same direction. It could be up or it could be down. Now, when a parabola has a positive a value, which direction do they go? So if I have 4x squared, which way do the ends go? Up or down? Up. Okay? So when my coefficient is positive, so I have a positive coefficient. Okay? I'm going to also write a positive a value. Okay? Then I go up. Now think about a quadratic. If I've got a negative coefficient, where does it go? Down. And they both go down. Okay? Negative coefficient, they both go down. Okay, now, students typically do fine with x squared, x to the 4th, x to the 6th. It's the odd powers that are confusing. Do not forget that y equals 2x plus 3 is an odd power. Don't forget that. As is x to the 3rd, x to the 5th, etc. Those are all odd powers. So what you want to do is you want to go back and think a little bit about slope. Think about how slope works. So when we are talking about odd powers, think about how slope works. So let's look at my first one. I have a graph that is moving in the general direction down in the left, up to the right. That is the general direction that I'm going. And that is the general direction of a line when it has a positive slope. Okay, now we're not talking about slope when I've got x to the 3rd or x to the 5th, but you can think about it like you do a line. I would stretch that graph out. Just in your brain, stretch it out. Does that have a positive slope or does that have a negative slope? Okay, so down here, you're looking at it in the same way when I have a negative coefficient as a negative slope. Okay, and that takes a little bit to get used to. But always refer back to your slope. What would the behavior be of a line? What would the behavior be of a line? Okay? Ooh, okay. Whoops. Take a picture of this. Okay. We're just going to practice a couple real quick. Okay? Now, I've got a negative coefficient and I've got a cubed exponent. So is my end behavior going in the same direction or opposite? Opposite. And it's going to be with a negative slope. So you can think about that as kind of a negative movement. Okay? Now, for my next one, I have x to the 4th, and that's all I care about. Same direction or opposite? Same, okay? Because it's to the 4th power. Both up or both down? Both up. Excellent. Okay? There it is. Both up. Okay? Okay. X to the 5th. Same or opposite? Opposite. Positive slope or negative slope? Good. So we've got that positive. It's not slope, but it kind of, we think of it as slope. Okay, I think I've got one more I want to do. Yeah, I do. One more. Okay. Opposite direction or same direction? Same direction. My end behavior is going to be in the same direction. Up or down? Down. Now, what I want you to think about, and this is where we're going to pick up, so I want you to think about this, and I want you to think about this, and I want you to think about the behavior of my graph at those 2 points. Okay? Have a fabulous day. I hope my recording will see.